the basic things which are most important for your all competitive exams, interviews in the field of electronics. Okay. So what is this symbol? Ground. What is ground? What is ground? Zero potential. Few people say zero potential, correct? But actually, have you understood what is ground? So ground can be defined considering two parameters. One is voltage and one is current. Okay. If I want to define the ground with respect to voltage, then I'll give you one simple analogy. I'm standing here. So if you ask me what is your height, I'll tell my height is 6 feet 1 inch. Then what is the base for that? What is the base for that means where is 0 feet? Where is 0 feet? The ground itself is 0 feet. Okay, so when I say in all our circuits that I am giving say 5 volts, I am giving 5 volts to the circuit. Okay, maybe anything in the circuit. So when I am giving 5 volts, where is the base? Base means 0. 0 feet. So if you measure from down till my tip of the head, you will measure the height. Okay. In the same way, as you are measuring from the base, that base is 0 volts, which is ground. Okay. So ground is nothing but the base for all circuits, which defines zero potential, and considering that zero potential as the base, we measure the voltages in the circuit. So if you want to measure the voltage at this point, what is the voltage across this resistor, then we will measure it, and we are measuring it with respect to ground. So 0 is the ground. Okay? Comparing 0, how much is the voltage present at this point? Say 3 volts or say 4.3 volts is present here. Then with respect to ground or with respect to 0 potential, this is at 4.3 voltage. This definition is with respect to voltage. Okay. So with respect to current, I just draw some circuit. So here I have one circuit. Okay, this is resistor. Okay. Here I have one circuit, and here again I have one circuit, 1 kilo, 5 volts. So you can consider the diodes are common, like same diodes are present in all the circuits. So you have 3 circuits in front of you. Okay. And one more circuit I can draw to confuse you all. Five volts. This is again 1 kilo. So 1, 2, 3 and 4. 4 circuits you are seeing. Now my question is, what is the difference between these 4 circuits? What is the difference between these 4 circuits? Whether they are same. If they are same, why they are same? If they are not same, why they are not same? So the answer is all four circuits are same. Now few people get confused. Sir, here there are two grounds. So one circuit will have only one ground. Though it is represented as two grounds here, it will have only one ground. Then you will ask why it is represented as two grounds. I say it is correct. This is also correct, this is also correct, this is also correct, and this is also correct. All four are correct. So when I say one circuit has only one ground, then why two grounds are shown here? So here we get the definition of ground with respect to current. Okay. So ground is nothing but returning path for the current. Returning path for the current means current is flowing here. Okay. People misunderstand. Oh, ground is there means it will go down. Just like we have ground in electrical. Earthing, we have earthing in every house, right? So if more power comes, it will be bypassed. So here also people think, okay, here is the circuit, so current finally it will go down to the earth. But we are not connecting anything to earth, we have the connection on breadboard. Correct? So definition of ground is nothing but it is the returning path of the current. This symbol indicates that the current will return back to its original or into its origin. So this is voltage source which can generate current. So this symbol indicates that yes, the current is passing and reaching here. Now you will ask here. So here you have shown the path also, and here you are showing the symbol also. Correct? So here I am not showing the symbol, but I say both are correct. Yes, both are correct. Because when you show the wire or returning path for the current, it is not compulsory to show the symbol. It is not mandatory that you should show both. It is not mandatory. If you just show the returning path for the current, okay, then I did not represent the symbol. It is not mandatory, and it is not wrong if I show it. So here I am showing the symbol of ground. It is not wrong. And here I am not showing the symbol of ground. It is also not wrong. Okay, both are correct. I can show or I can skip. It is optional. So ground with respect to current is defined as returning path for the current. Only this much. Clear? Understood what is ground? So you might have seen so many circuits in your laboratories. Say one amplifier. Correct? So you have circuits like this. This is voltage divider. R1, R2. So here you give some input to the amplifier. Here you have ground. Here you have ground. Here you have capacitor and ground. Then at the output collector, okay, you have the output which is measured with respect to again ground. So this ground, this ground, this ground, this ground, all are ground. Circuit will have only one ground. When you do it practically on breadboard, you will connect only to common points. But common point you connect not. So all these grounds are common and they are connected. And that indicates, okay, current will flow like this. Correct? Current will flow like this. Current will also flow like this. Current will also flow like this. these currents going like this, like this, like this, all these currents, they will come here to the ground, or I can show it like this. Here I will show you potential, voltage, that say 12 volts. This negative is connected to everything here. So what all current they are flowing, they will return back to this. They will return back to this. So I hope the ground is clear now. Any questions? Ground ಏನು ಅರ್ಥ ಆಯ್ತು? ಅರ್ಥ ಆಯ್ತು? Have any questions? Yes, you can ask. So next we will see I hope you know voltage source. Okay, so this is voltage source. Voltage source has a series resistance in it. It is inbuilt. So this is voltage source. And current source. Current source also has resistance. Okay, which is parallel. So say this is current source. This is current source. So what is the value of this series resistance, which is inbuilt? Voltage source has inbuilt series resistance. What is the value of that series resistance? Ideally, V by I. No. Even voltage source है ना, आ voltage पूरा voltage source, पूरा voltage source. Within this voltage source, there will be small series resistance, which is a part of voltage source. So my question is, what is the resistance of this small? Answer here. Answer here. The last word is small. That is the answer. This resistance is very, very small. Ideally zero. Ideally zero. Practically very few ohms. Okay. Why it is like that? Why it is like that? Because this is a voltage source. What it does actually? Voltage source ಏನು ಮಾಡ್ತದೆ? Voltage ಕೊಡ್ತದೆ. ಹೌದಾ ಇಲ್ಲ? Voltage ಕೊಡ್ತದೆ. Suppose if I connect this voltage source to a circuit, I am taking diode. So say this is 10 volts. I am giving 10 volts. Okay. What will happen if this resistance is not small? If it is high, what will happen? What will happen? Wait. The confidence is up. Yes. Correct. ಏನಾಗ್ತದೆ? See, the 10 volts voltage supply ಕೊಡತ್ತಿರೋದು. So you expect 10 volts to come out of that. 10 volts ಇಟ್ಟಿನ 10 volts ಹೊರಗೆ ಬರಬೇಕು ನಮ್ಮ ಎಕ್ಸ್ಪೆಕ್ಟೇಷನ್ ಇರ್ತದೆ. 10 volts should come out of that. If this resistance is more, then voltage across this resistance, what how much it will be? What is voltage formula? Ohm's law. So you consider two cases. One case, resistance is 0, and one more case, resistance is very high. Very high. You can take example 100 kilo ohms. Two cases started. Okay. So two cases voltage I into 0. 0. I into 100k. Some value I will get which is non-zero. Correct. So what is this V actually? Voltage across this resistor. Okay. Which is preferable? This is preferable or some non-zero is preferable? 0 is preferable. Why 0 is preferable? See, this is generating 9 volts. If 2 volts drops here only, 2 volts ಇಲ್ಲಿ ಡ್ರಾಪ್ ಆಯ್ತು ಅಂದ್ರೆ ಹೊರಗೆ ಎಷ್ಟು ಬರ್ತದೆ? 8 ಬರ್ತದೆ. ನೀವು 10 ಕೊಟ್ಟರೆ ಹೊರಗೆ 8 ಬರತೈತಿ. Is it efficient? It is not efficient. ಅರ್ಥ ಆಯ್ತು? So whatever it is generating, it should give out faithfully. ಪೂರಾ ಕೊಡಬೇಕದು ಹೊರಗೆ. ಇಷ್ಟು ಜನರೇಟ್ ಮಾಡಿ ಅರ್ಧ 40 ಬಿಡ್ತದೆ. ಅರ್ಥ ಆಯ್ತು? ಇದೆಲ್ಲ ಇಂಟರ್ವ್ಯೂಸ್ ಒಳಗೆ ಕೇಳ್ತಾರೆ ಕ್ವಶನ್ಸ್. ಫಸ್ಟ್ ನೀವು ಇದನ್ನು ಕೇಳ್ತಾರೆ, ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಬಿಡಿಸಪ್ಪ ಅಂತ ಕೇಳ್ತಾರೆ. ಅವಾಗ ನೀವು ಬಿಡಿಸ್ಬೇಕು. ಬಿಡಿಸ್ತೀರಿ, ತಪ್ಪು ಬಿಡಿಸಿದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರುವುದಿಲ್ಲ ಏನಾದ್ರು ಅಂತ ಕೇಳ್ತಾರೆ. ಇರ್ತದ, ಹೆಂಗಿರ್ತದ? ಸೀರೀಸ್ ಇರ್ತದೆ, ಪ್ಯಾರಲಲ್ ಇರ್ತದೆ. ಸೀರೀಸ್ ಇರ್ತದೆ, ಬಿಡಿಸ್ತೀರಿ. ಓಕೆ, ಇದರ ವ್ಯಾಲ್ಯೂ ಕೇಳ್ತಾರೆ. ಐಡಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ನಿಮ್ಗೆ ಗೊತ್ತಿದ್ರೆ 0 ಅಂತ ಹೇಳ್ಬಿಡ್ತೀವಿ. ಮತ್ತೆ ಯಾಕಂತ ಕೇಳ್ತಾರೆ, ಅವಾಗ ನೀವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀರಿ. ಈಗಿನ ಹೇಳಿದ್ರೆ ಬೇಕಾಗುತ್ತೆ. This is current source. Current source has actually resistance parallel to it. So what should be the value of this? Ideal value. It should give out the current. This is current source. So ಹೊರ ಕರೆಂಟ್ ಬರಬೇಕು. ಹೇಳಿ maximum. This should be maximum, ideally infinite. ಯಾಕೆ ಹೇಳ್ರಿ? ಸಪೋಸ್ ಇದು 0 ಮಾಡಿಬಿಟ್ಟು ಅಂತ ಹೇಳ್ತಾರೆ. ಇದು 0 ಮಾಡಿಬಿಟ್ಟಂದ್ರೆ ಕರೆಂಟ್ ಹಿಂಗೆ ಬರ್ತದ, ಹಿಂಗೆ ಹೊರಗೆ ಹೋಗಿಲ್ಲ, ಇಲ್ಲೇ ಹೋಗಿ ಇಲ್ಲೇ ಕೂತ್ಬಿಡ್ತದೆ. ಕರೆಂಟ್ ಸೋರ್ಸ್ ಮಾಡಿ ಉಪಯೋಗ ಇಲ್ಲ. What is the use of this current source if it is not giving the current outside to outer circuits? ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅದ ಮುಂದೆ. ಓಕೆ, ಈ ಸರ್ಕ್ಯೂಟ್ ಅದ ಅಂದ್ರೆ ಕರೆಂಟ್ ಹೊರಗೆ ಬರಕ್ಕಿಲ್ಲ ಅಂದ್ರೆ ಏನು ಉಪಯೋಗ? ಸೊ ಕರೆಂಟ್ should not rotate in this loop. Therefore, this should be infinite, ideally, practically very large. ಗೊತ್ತಾಯ್ತು? ಡೌಟ್ಸ್ ಇದಾವೆ? Voltmeter, ammeter. What is voltmeter? To measure the voltage. So how it is connected? Voltmeter is connected in series, parallel. ಇಲ್ಲಿ ವೋಲ್ಟ್ ಮೀಟರ್ ಇಲ್ಲೇ ವೋಲ್ಟೇಜ್ ಚೆಕ್ ಮಾಡಬೇಕಂದ್ರೆ ಹೆಂಗ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತೇವೆ? ಇದನ್ನು ಬ್ರೇಕ್ ಮಾಡಿ ಸೀರೀಸ್ ಆಗಿ ಹಚ್ಬಿಡ್ತೀರಿ. How ammeter is connected? How voltmeter is connected to measure the current and voltage? Ammeter is connected in series. Voltmeter is connected in parallel. ನೋಡಿ, ಇದು ಫಸ್ಟ್ ಕ್ವಶನ್ ಕೇಳೋದು ನಿಮ್ಗೆ. ಇದ ತಪ್ಪು ಕೇಳಿಬಿಟ್ರೆ ಮುಗಿದೋದು, ಮಾರ್ಕ್ಸ್ ಇದು ಹಾಕಿ ರಿಜೆಕ್ಟ್ ಇನ್ ಇಂಟರ್ವ್ಯೂ ಹಿಂಗಾಗ್ತದೆ. ಯಾಕಂದ್ರೆ ನೀವು ಲ್ಯಾಬ್ನಾಗ ಮಾಡಿರ್ತೀರಿ, ಫಿಸಿಕ್ಸ್ ಲ್ಯಾಬ್ನಾಗ ಆಂಬಿಟ್ ಯೂಸ್ ಮಾಡಿಲ್ಲ, ಸೀರೀಸ್ ಹಚ್ಚಿದ್ದಿಲ್ಲ. So ammeter is connected in series, voltmeter is connected in parallel. Now they will ask you what is the resistance of ammeter and what is the resistance of voltmeter. What is the resistance of ammeter? Resistance of ammeter ಅಂದ್ರೆ ammeter ಒಳಗಿನ resistance ಎಷ್ಟಿದೆ, voltmeter resistance ಅಂದ್ರೆ voltmeter ಒಳಗಿನ resistance ಎಷ್ಟಿದೆ. ಸಿಂಪಲ್ ಅದ, ಟ್ರೈ ಮಾಡ್ರಿ, 0 ಹಾಕಿ ನೋಡ್ರಿ, ಇನ್ಫೈನೈಟ್ ಹಾಕಿ ನೋಡ್ರಿ, ಏನಾಗ್ತದ ವಿಚಾರ ಮಾಡ್ರಿ, ನಾಳೆ ಹೇಳ್ಬಿಡ್ತೀನಿ, ಟೈಮ್ ಹೋಗ್ತದಿಲ್ಲ ಅಂತ. ವೋಲ್ಟ್ಮೀಟರ್ ಒಳಗ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ವೋಲ್ಟ್ಮೀಟರ್ ಇಸ್ infinite until y, resistance of ammeter is 0. ಯಾರು ಹೇಳ್ತೀರಿ ಯಾಕಂತ? What functionality we are expecting from that? Ammeter ಏನು ಮಾಡಬೇಕು? ಏನು ಮಾಡ್ತದ? ಮೆಜರ್ ದಿ ಕರೆಂಟ್. ಹೌದು, ಎಷ್ಟು ಕರೆಂಟ್ ಅದ ಮೆಜರ್ ಮಾಡ್ತದ. ಸೊ ಕರೆಂಟ್ ಬರೀ ಮೆಜರ್ ಮಾಡ್ತದಿಲ್ಲ, ಏನು ಕರೆಂಟ್ ಚೇಂಜ್ ಮಾಡಿಬಿಡ್ತದೆ, ಬರೀ ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಅಷ್ಟಿಲ್ಲ. ಸೊ ಇದರ ರೆಸಿಸ್ಟೆನ್ಸ್ 0 ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ಅಡಿಷನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಹಾಕದಂಗಾಯ್ತು ನಿಮ್ಮ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ. ಸೊ ರೆಸಿಸ್ಟೆನ್ಸ್, ಇಲ್ಲೊಂದು ರೆಸಿಸ್ಟೆನ್ಸ್, ಇನ್ನೊಂದು ರೆಸಿಸ್ಟೆನ್ಸ್, ಎರಡು ರೆಸಿಸ್ಟೆನ್ಸ್ ಆ್ಯಡ್ ಆಗ್ತದೆ. ಆ್ಯಡ್ ಆದರೆ ಕರೆಂಟ್ ಡ್ರಾಪ್ ಆಗ್ತದೆ. ನಾವು ಡ್ರಾಪ್ ಮಾಡಕ್ಕೆ ಹಚ್ಚಿಲ್ಲ, ಇದನ್ನು ಏನು ಮಾಡಕ್ಕೆ ಹಚ್ಚಿ, ಮೆಜರ್ ಮಾಡಕ್ಕೆ ಅಷ್ಟೇ ಹಚ್ಚಿ. So when I connect ammeter in series, it should not affect the current, it should only measure the current. How it can measure the current and how it cannot affect the current when its resistance is 0. Zero resistance ಹಚ್ಚಿದ್ರೆ ಏನು ಇಫೆಕ್ಟ್ ಆಗ್ತದೆ ಕರೆಂಟ್ ಮೇಲೆ? ಏನು ಇಫೆಕ್ಟ್ ಆಗ್ತದೆ? No effect. Current will flow as it is. And I will simply measure it. Okay. So resistance of ammeter is 0. Now this one. Resistance of voltmeter. What is the resistance of CRO? What is the resistance of CRO? Use ಮಾಡಿರಿ ನೀವು, ಕನ್ಸರ್ನ್ ಯೂಸ್ ಮಾಡಿಲ್ಲ, CRO ಯೂಸ್ ಮಾಡಿರಿ, ಎಷ್ಟಿದೆ? ಬರ್ದಿದ್ದೈತಿ ಅಲ್ಲೇ, ನೀವು ನೋಡಿಲ್ಲ ಅಲ್ಲಿ, ಎಲ್ಲಿ ನೀವು ಪ್ರೋಬ್ ಹಚ್ತೀನಿಲ್ಲ ಅಲ್ಲಿ ಬರ್ದಿದ್ದೈತಿ, ಯಾರು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ? It is very high. Mega ohms, 20 mega ohms. Go check for ಲ್ಯಾಬ್. Okay. So voltmeter resistance infinite, ideally infinite ಇರಬೇಕು, or practically too high, very large. ಯಾಕಂದ್ರೆ ಮತ್ತೆ ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಬರ್ಲಿಕ್ಕೆ ವೋಲ್ಟ್ಮೀಟರ್ ಏನು ಮಾಡಲಿಕ್ಕೆ ಹಚ್ತೀವಿ ನಾವು? ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹಚ್ತೀವಿ, ಕರೆಕ್ಟ್? ಈಗ ನಮ್ಗೆ ಇಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಎಷ್ಟೈತಿ? I want to measure at this point, between these 2 points. Okay, point A and point B, I want to measure the voltage. Okay. Now, if the voltmeter's resistance is 0, what will happen? Current will come like this, it will come like this, and now at this point, current will flow like this because 0 resistance. Current always prefers low resistance path. Correct? Therefore, current will start flowing through voltmeter and it will not flow through resistor. At that moment, what reading will be seen? 0. ಯಾಕಂದ್ರೆ ಇದನ್ನು ಕರೆಂಟ್ ಬಂದಿಲ್ಲ 0 into R 0. ಪರ್ಪಸ್ ಸರ್ವ್ ಆಯ್ತು. ನಮ್ಮ ಪರ್ಪಸ್ ಏನಿತ್ತು? ಮೆಜರ್ ಮಾಡಬೇಕಿತ್ತು. ಏನು ಮೆಜರ್ ಮಾಡಬೇಕಿತ್ತು? ವೋಲ್ಟೇಜ್. So we wanted to measure the product of current and resistance. This into this ಎಷ್ಟು ರೀತಿ ನೋಡುವುದಕ್ಕೆ ನಮಗೆ ನಾ ಇದನ್ನ ಚೇಂಜ್ ಮಾಡಿಬಿಟ್ಟೆ. ಇದರ ಥ್ರೂ ಎಷ್ಟು ಕರೆಂಟ್ ಹೊಂಟಿತ್ತು ಅದು ಪೂರಾ ಇದರ ಥ್ರೂ ಹೋಗ್ಲಿಕ್ಕೆ ಅಂತಂದ್ರೆ ಈ ವೋಲ್ಟೇಜ್ ಉಳಿಯಂಗಿಲ್ಲ. Therefore resistance of voltmeter should not be 0 but it should be infinite. Infinite ಇದ್ರೆ ಏನಾಗ್ತದೆ ಹೇಳಿ? ಈ infinite resistance ಹಚ್ಚಿದ್ರೆ ಕರೆಂಟ್ ಹಿಂಗೆ ಹೋಗೋದೇ ಇಲ್ಲ. ಕರೆಂಟ್ ಆಸ್ ಯೂಶುವಲ್ ಹೆಂಗೆ ಹೊರಟಿತ್ತು ಹಂಗ ಹೋಗ್ತದ. ನಾ ಎಕ್ಸ್ಟ್ರಾ ಹಚ್ಚಿನಿ ಇದನ್ನ. ಸೊ ಕರೆಂಟ್ ಹೋಗ್ತಿರ್ತದ, ನಾ ಮೆಜರ್ ಮಾಡಿಬಿಡ್ತೀನಿ. ಕ್ಲಿಯರ್? ತಿಳಿತು? ಇದು ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಇಲ್ಲ? ಗೊತ್ತೇ ಇರಲಿಲ್ಲ. ಅದ ಇದಕ್ಕೆ ಮುಗಿತು. ಅರ್ಧ ಅಲ್ಲ, ಆಲ್ಮೋಸ್ಟ್ ಮುಗೀತು. ಸಿಕ್ಸ್ ಮುಗೀತು ಬಂತು. So resistance of most of the devices which are connected in parallel is infinite. Measuring devices is infinite. Do you know about the very simple problem. One simple problem to already. They will starting one simple problems to होता है वो. One step assista देंगे. So here they will ask you find the voltage between the point A and point B and point B and point C. So you need to find VAB and VBC. Now don't get confused with point P is इधे point इधू पूरा same point है. Okay. This is same point. Answer. Answer. Either VAB either people are giving me shock. What this indicates? Silicon, Akka. silicon diode will hold how much voltage? Answer hela tirla nive. ये मतलब ಈ ನಡು ವೋಲ್ಟೇಜ್ ಎಷ್ಟೈತಿ? ಎಷ್ಟೈತಿ? 0.7 ಐತಿ. ಆನ್ಸರ್ ನೀವೇ ಹೇಳಿದ್ರಿ. ಬಿ ಮತ್ತು ಸಿ ನಡು ಎಷ್ಟಿರಬೇಕು? ಎಷ್ಟಿರಬೇಕು? 9.3 ಇರಬೇಕು. ಯಾಕೆ ಇರಬೇಕು 9.3? ಯಾಕೆ ಇರಬೇಕು? Kirchhoff's law tells us that, especially KVL. KVL, what it tells? It tells us, I'll tell it in very simple language. Whatever voltage you are giving, that entire voltage should be distributed in the entire circuit. Means supply voltage is equal to remaining voltage. 10 volt ಕೊಟ್ಟಿರಂದ್ರೆ this plus this just elements ಹಚ್ಚಿರ್ತೀರಿ, ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಅಕ್ರಾಸ್ ವೋಲ್ಟೇಜ್ ಆಡ್ ಮಾಡಿದ್ರೆ 10 volts ಬೇಕು, ಇರಲೇಬೇಕು, ಇರ್ತದ. ಓಕೆ, ಸೊ 10 ಕೊಟ್ರೆ ಇಲ್ಲಿ ಎಲ್ಲ ಕೂಡಿ 10 ಇರಲೇಬೇಕು. ಸೊ VAB plus VBC is 10. You apply KVL if you want. You can apply KVL. Okay. So answer is 0.7 is VAB because it is silicon diode. VBC is 9.3. VBC is 9.3. Remaining voltage comes across this because it will hold only 0.7. 0.7 ಅಷ್ಟೇ ತಗೋತದ. Now tell me the answer. Same question. What is VAB and what is VBC? So think about this diode, whether it is on or off. It is on or off. Pakka it is off because it is reverse bias. I hope you know what is forward bias, reverse bias. So it is off. So when it is off, it acts like open circuit. Now the answer is very easy. What is the current flowing through this? What is current flowing through this? 0. So what is V is equals to? V is equals to I into R. What is I? 0. So across this resistor, I is 0 and R may be anything. Okay. So voltage across B and C is 0. It is 0. Okay. Now 10 volts is applied, but current is not flowing through the circuit. It is open circuit. Here we have a socket. 230 volts is coming. You insert two wires. Okay. And just measure the two wires. Check the voltage across two wires from that socket. How much you will measure? Don't touch it. I am giving the hint. Tell the answer. Wires are coming through the socket. Switch it on. Don't touch the wire. Just measure. Just what the answer ಹೇಳಿದ್ರಿ correct ಅದ ಎಷ್ಟು 230. So here also I am giving 10 volts. Here is one wire. Same case. How much voltage will come across this? How much voltage will come across this? 10 volts. So here the answer is 10 volts. Here the answer is 0.